So now we're having a look at question number 3. And question number 3, it says the box below contains the names of the 5 quadrilaterals: trapezium, rhombus, kite, square, and rectangle. It says choose the one quadrilateral from the box that best completes each statement. A dash has no lines of symmetry and has a rotational symmetry of order 1. Now, what is line of symmetry? In other words, line of symmetry is that line that pretty much you can cut the object in a half. You can cut it in 2 halves, 2 even halves. All right? So 2 perfect lines of symmetry, a trapezium would be out. A trapezium has no line of symmetry. This is a trapezium. There's no way we can get this to be symmetric. All right, so when you think about symmetric, like a quadratic graph, right? And you could label the line of symmetry, all right, which would be that vertical line right there. You cut it in half and it look like a reflection of each other. But for a trapezium, there's clearly no line of symmetry right here. So if there's no line of symmetry, then clearly it has to be the trapezium. So the first one right here, this is trapezium. Now it says a dash has exactly 2 lines of symmetry and 4 right angles. The key thing, it says exactly. Now there are 2 of them that has exactly 2 lines of symmetry. It can be the rhombus or the rectangle, but then it says it has 4 right angles. A rectangle has 4 right angles and not a rhombus. This is a rectangle. It has 2 lines of symmetry. We can split it in half this way. See that side and that side. The left side and the right side would look the same, or we can split it this way. All right, so that's 2 lines of symmetry, but also 4 right angles. So this is definitely the rectangle. All right, now this says a dash has 1 line of symmetry. That 1 line of symmetry, that one is going to be the kite. All right, from all the options we have right there, that's the kite. Couldn't be the rhombus and it couldn't be the square. So the only option remaining is the kite. All right, so a kite has 1 line of symmetry, and the line of symmetry just means that, you know, we can cut it in half. So if I were to show you a kite, this is it's not the best looking kite. Just bear with me. This is my kite right here. All right, that's my kite. The kite, this yellow line would be the 1 line of symmetry. Can cut it in half that way. All right, so that's the line of symmetry. We can see both sides are symmetric to each other, the left and the right side of the yellow line. All right, now part B says the diagram shows 4 straight lines, of which 2 lines are parallel to each other. So these 2 lines are parallel to each other. Determine the value of Q and R. So now the first one, Q. What is the value of Q? Now, what I like to do first, this is just my preference. I like to always write down alternate angles first and foremost. So we already know R is 54 degrees. R is 54 degrees by vertically opposite angles. R is 54 degrees. This angle right here is 54 degrees by vertically opposite angles. That's the rule that we use. All right, vertically opposite angles. All right, that was the rule that we use. And then, because these 2 lines are parallel, what else do we know? Because these 2 lines are parallel, then we know that co-interior angles sum to 180. So what does that mean? That means that angle R plus angle Q is equal to 180 degrees. because co-interior angles are adding up to 180 degrees, but R is 54. So Q is going to be 180 minus 54. If we put that in our calculator, I'm pretty sure it's going to be 126 degrees. All right, and that's because of co-interior angles. All right, really nice. So that takes care of P and Q. That takes care of R, and Q. Now, the next part of the question says, give a geometrical reason why angle P is 71 degrees. So angle P, they're telling us this angle right here is 71 degrees using a geometric reason. But the geometric reason is clear. This is Z angles. Hey! If you remember, we have two parallel lines. These are the parallel lines. And then we have a transversal line. Any line that intersects two parallel lines, we'll call that the transversal line. Then we can apply Z angles. So angle P is equal to angle 71 by Z angle theorem or alternate angle theorem. So that's what we're going to write. By alternate angle theorem, angle P is equal to 71 degrees. So that's why you need to know the theorems. All right, so by alternate angle theorem, put in bracket Z angles theory. We can tell them angle P is 71 degrees. All right, that's the theorem that we use, alternate angle theorem. All right, that's the theorem that we use. Alternate angle theorem, or some people like to call it Z angle theorem. All right, now the next part of the question says, the diagram below shows triangle X prime, Y prime, Z prime. I'm just gonna zoom a little bit more. All right, so I've zoomed a little bit more so I can see what it is saying. All right, it says the diagram below shows triangle X prime, Y prime, Z prime, and X double prime, Y double prime, Z double prime drawn on a square grid. It says triangle X prime, Y prime, Z prime is the image of triangle XYZ after an enlargement of scale factor 2 with the center being 5, 1. So let's put on the center. Let's just put on the center right now. The center is when X is 5, the Y value is 1. This is the center of enlargement. I like to call my center of enlargement C. All right. Now here's what they say. They say draw triangle XYZ, the object from triangle X prime, Y prime, Z prime on the grid. Okay, no problem. Now, how are we going to do this? In order to draw the object, what you need to do is first realize that the center is not the origin. So what I like to do is call this my fake, this origin now, I like to call it my fake origin. This is now like my fake origin. Imagine this as your fake origin. Imagine this as your fake 0, 0. So I'm going to use yellow lines to just indicate my fake origin. This is my fake origin. If this is my fake origin, picture C as the point 0, 0. If C is the point 0, 0, that is like Z prime now would then be 1, 2, 3. Z prime would be 1, 2, 3, 4, 5, 6, 7. Let me check again. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, that's 8. So that's negative 8. And then I'm going up 1, 2. In that case, my Z prime, the fake, notice I keep saying fake Z prime is, let me write fake at the top. All right, so my fake z prime is -8, 2. And if the scale factor is 2, then to find my actual z, I need to divide this point by 2. Divide it by 2, and I would get -4, 1. All right, you have to divide it by scale factor. This is what we divide it by. We divide by the scale factor. So now we divide it by 2. That's going to give us the point -4, 1, but -4, 1 is our fake z. So from the fake center, we'll go 1, 2, 3, 4. Going to the left is negative, so that's -4 and 1 upwards. So that is at this point right here. This is our z. All right, so the real z, you can write down the real coordinates of z if you want, but this is where z would be. All right. Next now, we need to write down our fake, maybe I'll go with x prime. The fake x prime would be 1, 2, 3, 4, 5, 6, 7, 8 to the left, so that's -8. And 1, 2, 3, 4, 5, 6. 6 units upwards. So my fake x prime is -8, 6. So when I divide that by 2, my x is going to be -4, 3. That's my fake x. So -4, 3 is going to be 1, 2, 3, 4 to the left is negative. Then 3, 1, 2, 3 right here. This is my x then. This is my object x. All right. And finally, we can write down our y prime, which y prime is going to be 1, 2, 3, 4, 5, 6. All right, so y prime is -6 because we went to the left. Then going upwards is positive. 1, 2, 3, 4, 5, 6. That's also 6. So therefore, y is going to be dividing it by 2. I get -3, 3. -3, 3 from our center. Negative mean we go to our left. 1, 2, 3, then 3 units upward. 1, 2, 3. This is right here. And that would be my y. And then, of course, you connect them together. All right. So it's not going to be so pretty from my end because I'm not necessarily doing it on the actual graph sheet on the exam paper. I'm just using some straight edge, but make sure that yours is very, very neatly done. All right, so this is what you have right there. That's the triangle. I know it's not the best looking one, but that's okay. And just to show them that the center of enlargement is indeed 5, 1, what we're gonna do is look at this. We're gonna take out now a red line, and look what we're gonna do. We're gonna draw a line from the center. You're gonna notice that it's gonna pass through the image and the object point. They're all gonna intersect at 5, 1. Just to show you that the center of enlargement is indeed 5, 1 right here. All right, so look at this. Image and object point all pass through 5, 1, just to show you that it is indeed the center. All right, I'm just justifying that it is indeed the center of enlargement. All right, nice. So that completes that part right there. We have our image on the diagram and we're good. Hey! Now, triangle x prime, y prime, z prime is mapped onto triangle x double prime, y double prime, z double prime by reflection in the line P. State the equation of the mirror line. So they're telling us that the two triangles that we're looking at is a reflection of each other. The two big triangles, they're a reflection of each other. We need the mirror line. So let's first count out the distance from each other. 1, 2, 3, 4, 5, 6. If they're 6 units apart, then the mirror line going to be in between, in the middle at 3 units. So that's 1, 2, 3. This is the middle ground right here. So this is going to be our mirror line. In that case, the mirror line is going to be Looking at it, this look like x equal 2. Because as you can see, the distance from here to here, the distance from y prime to the mirror line is 3 units. And the distance from y double prime to the mirror line is also 3 units. So now we can write down and tell them that the mirror line is a line x equal to 2. To state the equation of the mirror line, x equal 2. That's the equation of the mirror line. All right, really nice.